The universe is not what you think it is. That's because what you can see is only a tiny fraction of it.
We have no idea what 95% of the universe is. It hardly seems that we understand everything.
Maybe we're just going to have to scratch our heads and start all over again.
It begs the question, why is 95% of the universe missing? For decades, physicists have been trying to find this elusive, undetected part of our universe. And in the beginning, we just had a name for it: dark matter. So what is dark matter?
Sounds exotic, but it doesn't have to be. There's a lot of dark things out there in the universe. Until I shine my light at these bottles, I can't see them. Dark matter could just be ordinary stuff that you can't see.
Now, what we do know about dark matter is that it's matter that doesn't interact with light, so we can't see it. But we know it's there because of its effects due to gravity, because of the way that stars orbit the centers of galaxies. The stars on the edge move a lot faster than they should, so there has to be more matter out there on the outskirts.
Well, there's an alternative idea for what the dark matter could be. And so what we think it is that it's some new kind of fundamental particle. Not neutrons, not protons, not ordinary atomic stuff, but something entirely new. And these particles are everywhere in the universe. They're flying around in our galaxy. They're in this room. Actually, there'd be billions going through you every second. You don't notice, but they're there.
So this invisible matter that dictates how our universe works is known by particle physicists as WIMPs, weakly interacting massive particles. If we can't see them, how do we find them? Part of the problem is that here on Earth, we're searching through a relative swamp of ordinary matter that we can see, which kind of blocks our view of the stuff that we can't see.
If you were to try to build one of these experiments in a laboratory on the surface of the Earth, then your signal would be completely swamped by cosmic rays. They would just ruin your attempt to do the experiment because the count rate from the cosmic rays would be so high that you'd never be able to see the WIMPs.
And that's why scientists are doing something that at first might seem pretty strange. They're going underground and searching in the dark.
After walking a mile underground like this, you have to wonder about the fact that we may be looking in the wrong place. This is the inner vessel of Pico 2L, we call this project, and it goes inside that big recompression chamber. We put a liquid in there, what we call a superheated liquid. It makes it sensitive to radiation. So when particles strike the liquid that goes in there normally, it's now empty, they produce bubbles. Piezoelectric sensors, they are very sophisticated microphones, and through sound we are actually able to differentiate between different types of particles as well.
What sound would dark matter make?
It's actually very soft, it's not the loudest.
But of course, there's a chance that looking for dark matter in this way, by essentially listening to it to see if it makes an appearance, might never be possible.
You do your job the best you can and then you hope for the best, but nobody knows if there's WIMPs out there or not. We're trying.
Now, other scientists are searching for this mysterious dark matter by using the world's largest physics experiment at CERN in Switzerland, the Large Hadron Collider. They're not listening out for it, they're attempting to make some from scratch. What they're doing is smashing together known particles at huge speeds to create huge energies in these impacts that might just spew off some particles of dark matter.
When the protons collide, most of the time the particles they produce, nearly always some new particles are created, but they tend to be low mass particles. But sometimes, very rarely, you produce these much more massive particles, and these are the guys that we're really looking for.
So the search for dark matter continues in underground labs and at CERN, and also by observing the night sky. And scientists believe they're getting closer to discovering what it's made of. But will we ever find it?
You have to accept the evidence. And if it turns out that I wasted my life working on the wrong hypothesis, so be it. What I really want to know is, what is the universe made of?
I can really see it as being a particle in nature, and I'm really driven, as we all are driven here, to try and find it.
And if you don't?
We will dust ourselves off and move on.
Whatever they do find will surely change the laws of physics as we know them. With scientists pushing new technologies and the boundaries of our knowledge, what's more, we've now realized that dark matter is only just the start of the story.
So 15 years ago, some astronomers observing distant supernova saw that the distance to those supernovae was larger than they expected. And so the only way that they could understand that was to have a universe that started accelerating 3 billion years ago. And whether that carries on accelerating or not, we don't know. But what we do know is that there has to be another component to the universe, which we call this dark energy.
But you don't know what it is.
No idea. Not at all.
No one knows what it is.
No one. No one. There are more theories than there are theoreticians.
So whilst dark matter might make up 25% of the unknown stuff in the universe, there's this whole other whopping 70% made up of something called dark energy. We know even less about dark energy. It's so weird and so unknown to us that we're actually going to need a whole other video to find out about it.